Welcome to homework.
So in this question, we have been given the angle at which the element will be oriented. That is 30 degrees clockwise, right? So if it's 30 degree clockwise, so it means that it's negative, right? Since we agreed in the theory of this chapter that the angles that are clockwise only, they will be considered positive. And this is clockwise, right? So clockwise will be considered negative and counterclockwise will be considered positive. Now they have also given us the value of the strain that is acting in the x direction, that is 500 into 10 raised to power negative 6. Then the value that is value of the strain that is acting in the y direction, right? And it's equal to 350 into 10 raised to power negative 6. And they have also given us the strain that is equal to negative 430 into 10 raised to power negative 6. Right, now what we need to do is that we need to find out the value of the normal strains, right? So these normal strains, they are basically epsilon sub x dash and epsilon sub y dash, right? And we need to find out the value of the shear strain as well. So for that, we're going to use the equations um, 10.5 to 10.7, right? So we are going to start from equation 10.5 and use it to find out the value of um, the normal strain that is acting in the x direction, right? So it's equal to the uh, average of these strains, positive, the difference of these strains divided by 2 times sine 2 theta, right? Sorry, it's not sine, it's cos 2 theta, right? And plus gamma sub xy divided by 2 sine 2 theta, right? You have the values, so just plug them in and you'll get that it's equal to 6.4896 into 10 raised to power negative 4, and that is approximately equal to 649 into 10 raised to power negative 6. Right, next what we are going to do is that we are going to use equation 10.6 and find out the value of the shear strain, right? And that is basically gamma sub x sub y, right? That is divided by 2 equal to negative the difference of the strains divided by 2 times sine 2 theta plus gamma sub xy divided by 2 cos 2 theta, right? Again, you have the values, so you just need to plug them in. And after plugging them in, you also need to shift this to the right hand side. So when you'll do that, you get that gamma sub x sub y, it's equal to negative 85.1 into 10 raised to power negative 6, right? Now that we have the values, we can use equation 10.7, right? And find out the value of the normal strain that is acting in the y direction, right? So strain that is acting in the y direction, it's equal to the sum of the strains that is acting in this system, in this question, right, divided by 2, negative the difference of the strains divided by 2, right? And over here we have cos 2 theta plus gamma sub xy divided by 2 times sine 2 theta. Again, you have the values, right? So you just need to plug them in. So you get 2.0130 into 10 raised to power negative 4. That is approximately equal to 201 into 10 raised to power negative 6, right? So now that we have all the values of the trace, we just need to sketch it. So as you can see over here in shape A, right? In the shape A, you can see the original element, right? The original element, right? Now in shape B, this element, it has been shifted 30 degrees counterclockwise, right? As you can see. Um, negative 30-degree, right? And in part C, you can see that how this train has deformed the shape of the element. Now this solid black line figure, it shows the original shape, and this dotted line shows the deformed shape of this element, right? And the shape sketch D, right, it shows the complete sketch of this question. So this concludes our answer.